Welcome students. Today we're going to learn Notes 11-6, which is the areas of regular polygons. And before we get started, we're just going to go over some vocabulary terms. I've already drawn the pictures for you, so we're just going to fill in the definitions. Okay, so first of all, circumscribed circle. That is a circle that contains the vertices of an inscribed polygon. Okay, and as you can tell over here to the side, I have a six-sided shape. This is a hexagon, and you'll see a dotted circle around it. That is your circumscribed circle. It's drawn around the shape. And what you have to pay attention to is you have to make sure that every single one of the vertices of the polygon is actually sitting on the circle. All right, next, center of a polygon. Well, the center of a polygon is going to be the center of that circumscribed circle. So, the center of its circumscribed circle. Next, radius. Well, here it's the segment that's connecting the center to one of the vertices that's on the circle. So here, that's going to be the radius of its circumscribed circle. Okay, so remember, it's the segment that's going from the center out to the circle. It's a normal radius, but it's also going to be connecting, it's where the vertex or one of the vertices of the polygon is sitting on the circle. Apothem. The apothem of a polygon is the distance from the center to any side of the polygon. Okay, so if you look here, it's going to be this segment that's connecting the center to the side of the polygon. And remember, since it's called the distance, it's going to be perpendicular to the side of that polygon. Okay, so make sure you see that this is a right angle. Next, central angle. A central angle, remember, of a circle is where the center was sitting, or the vertex of the angle was sitting on the center of the circle. Well, this is the same thing. The vertex of the angle is going to be on the center of, like this up here, the center of the polygon, and it's going to be connecting two radii. Okay, so here we define it as an angle formed by two radii drawn to consecutive vertices. So it's not going to be this one and this one. They have to be consecutive. They have to be right next to each other. Drawn to consecutive vertices of the polygon. Okay. Now, to find the area of this shape here, we don't have a formula just like that's unique to this shape, as if we had one for square, triangle, rectangle, or circle. So all of them, regular polygons, no matter how many sides it has, it's always going to be this one basic formula. The area A, capital A, of a regular n-gon is half the product of the apothem and the perimeter. Okay, so here you see the shape, you see all of the central angles drawn, you see the apothem drawn, and you see the side over here is labeled S. Okay, so here, the very first thing you want to write down here is that N stands for the number of sides that the shape has. You want to remind yourself about that, and you also want to write down that the perimeter, capital P, is equal to N, the number of sides, times whatever that side length is, which is S. Okay? Alright, so up here, what this says is that the area is equal to 1/2 the apothem. We're going to use lowercase a for the apothem and a capital P for perimeter. So 1/2 the apothem times the perimeter. Or you could think of it as 1/2 the apothem, but then for the perimeter you could substitute in N times S. Okay, just remember that A stands for the apothem, P stands for perimeter, N is the number of sides, and S is the side length. Okay, so now we're going to get started with all the examples. We're going to start with triangle. Alright, so remember that these are regular polygons, so that means all the sides are the same. So this is an equilateral triangle. And what we know about an equilateral triangle is that all the sides are congruent and all the angles are congruent. Okay, that's going to be important information in a minute. Okay, so here, I'm going to start with the name, triangle. That means that my N is equal to 3. 3 sides. Okay, so a radius and an apothem, that means I'm going to have to do some drawing. To draw my apothem, I'm going to start here with the center, and I'm going to draw a segment straight down to the base so that it's perpendicular. That segment right there, perpendicular to that side of the triangle. To draw my radius, I go from the center out to the corner. Okay, so that creates this triangle here. And that triangle is important for us to help us find all the missing information that's up here. Okay, first, I'm going to take this triangle right here. I'm going to shade this in pink. And all I'm going to do is enlarge it over here. So this right here. And let's talk about everything we know about that triangle right there. Well, first of all, this is an equilateral triangle, remember, so each one of these angles is congruent. That means that they are each 60 degrees. And a radius is going to come in and act as an angle bisector. It's going to cut that angle in half. So that means that this one here is 30 degrees. So I'm going to label this 30 degrees. Well, if that's 90 and that's 30, you know that this is a 30, 60, 90 triangle. So that's a special right triangle. Okay, so now this was the apothem, and this was the radius, and this whole thing is the side length. But this little piece right here is going to be half of the side length. So I'm going to label this with X. Okay, and I want you to remember that X stands for half of a side. Okay, now I'm going to write down all the information that I know. Here, this is the apothem. This right here is the apothem. This right here is the radius. And this was half, this guy right here is half the side of the triangle. Okay, now I'm going to draw my unit special right triangle. That's on my formula chart, so I'm just going to make sure that it's on my notes. So that's 30, that's 60 degrees, and that's 90 degrees. So remember, if this is the short side, that's going to be x. This will be the hypotenuse, so that's going to be 2x. And this is going to be the long side, the long leg, so that's going to be x rad 3. And you can find that on your formula chart. Okay, so what I know from what's given to me up here in this information, in this table, is that the radius is 10. So I'm going to put 10 right here. It's 10 units. Okay, so if that's 2x, to find x, I'm going to cut it in half. So that means that my apothem, 10 divided by 2, is going to be 5. So my apothem is 5 units. Okay, now to get x here, remember I labeled this x, to get x, this side length here, half the side length, I have to multiply the apothem times rad 3, so this is going to equal 5 rad 3. Now of course that 5 rad 3 goes there and 5 rad 3 goes there, so when we're talking about the side, we're talking about the side of the entire triangle. So 5 rad 3 and plus 5 rad 3 make 10 rad 3. That's going to be units. Okay, now perimeter, remember, perimeter is the number of sides times the side length. The number of sides is 3, so this is going to be perimeter equals 3 times 10 rad 3. Folks, don't forget that whole numbers you multiply together, rads you multiply together. So this will be 30 rad 3 units, because perimeter is measured in units. Alright, to get the area, we just learned that the area is equal to 1/2 the apothem times the perimeter. So to find the area of this triangle, and that's all I know is the radius was 10, I don't know base or height, so I can't use my normal formula, then that's going to be 1/2 the apothem, which is 5, times the perimeter, which is 30 rad 3. Okay, so that's going to be 1/2. I'm going to multiply 5 times 30, which is 150 rad 3. And so that equals half of 150 is going to be 75 rad 3. So that's going to be 75 rad 3, and yes, that's units squared. Okay, so we couldn't use our normal formula for this because we weren't given the base and we weren't given the height. All we were given was the radius. So that's how you find the area of a triangle when you're just given a radius. The next one, square. What we're given here is that the side length on this one is going to be 6 rad 2. So we can find the area of this one, 6 rad 2, because it's going to be side times side, because that's how you find the area of a square. But I'm going to walk you through this so that in case you're given an apothem or a perimeter or a radius sometime, so that you can make sure that you understand how to get all the pieces. Okay, so here we know that this is a square, so first of all we know that n is equal to 4. I know that since it's a square, I know that all of these are right angles, and I know that all of these sides are congruent. I'm going to start by drawing my apothem. So that's going to be from the center straight down to the side. It's a right angle. And then I'm going to draw my radius, which is over here to the corner. Okay, so now I'm going to recreate. I'm just going to zoom in and blow this up. I'm going to draw it over here. Here's my purple triangle. Okay, so I'm blowing it up. So since this one right here is a 90-degree angle, but since this over here was a 90-degree angle and its radius came in and acted as an angle bisector, I know that this is going to be 45. And if that's 45 and that's 90, this has to be 45 up here. Okay, so that's a special right triangle. And on my formula chart, what I know about my special right triangles, I'm going to draw it real small right here. This is 45, 45, 90. I know this is x, this is x, this is going to be x rad 2. And you can find that on your formula chart. Alright, so what I'm given here is that this whole side here is 6 rad 2. But this part of the triangle is half of that. So that's going to be 3 rad 2. Okay, so that means that I can find the apothem very easily, because remember, this over here is the apothem, and I know that these two sides are the same, so the apothem is equal to 3 rad 2. So I'm going to write that up here, 3 rad 2 units. And of course this should have units. Okay. Alright, and so the next thing that I can find is I can find my radius. Alright, so here, if I know that this is 3 rad 2, I know my radius. All I have to do is take my side length, which is 3 rad 2, and multiply it by rad 2. Okay, well, you multiply the insides of the radicals together, so that's going to be 3 rad 4. And we know that that reduces to 2, so that's just going to be 3 times 2, which is 6. So my radius is 6 units. Okay, so this equals 6. Okay, to find my perimeter is just the number of sides times the side length. So for my perimeter, all I had to do is take my n, which is 4, and multiply it by 6 rad 2, which is what I was given. So I multiply the 6 and the 4 together, so that's going to be 24 rad 2 units. Okay, the area. The area is going to equal 1/2 the apothem times the perimeter. So area equals 1/2 the apothem, which is 3 rad 2, times the perimeter, which is 24 rad 2. Now remember, you put the outsides and the in together, and you put the insides together. So this is going to be 1/2 times, and that's going to be 72 times, and then that's going to be rad 2 times rad 2, which is rad 4. Okay, so I'm going to multiply all those numbers together. Okay, so half of 72 I know is 36. Rad 4 is 2. So now, to find my area, I just multiply 36 times 2. Okay, so that's going to be 72 units squared. And remember, we knew that the side was 6 rad 2. So if we use the old formula on this one to double check to make sure we got it right, okay, I'm going to change colors just so you know that I'm just using this to make sure I have it right. Area is equal to 6 rad 2 times 6 rad 2, which is 36 times rad 4, which is 36 times 2, which is 72. So, see, we got it right. Okay, I'm putting that in a little cloud because that's how we would do it if we had the side, but we wanted to fill out this chart, so we wanted to know the radius, the apothem, and the perimeter and the area anyway. Okay. Next, now that we've done these two, and we can do the same steps that we went through. Notice how both of those were simplified radicals for the answers. This one is going to be rounded to 4 decimal places. That should clue you in that 4 decimal places means I'm going to be using trig. Okay, so I'm going to start here. I'm going to draw my apothem. Okay, here's my apothem and my radius. Okay, here's my orange triangle. Okay, so here, pentagon, that means my n is equal to 5. I know this is the apothem and this is the radius. I'm going to draw this a little bit bigger. Okay, this is my apothem, and I know my apothem is 8. I know this is my radius. And remember, this over here, that's x because it is half of the side of the pentagon. Okay. Now, I don't know anything about the angles because it's not like I knew this angle right here. I can find that angle, but it's easier if you find the central angles. Now remember, a central angle, I'm going to draw this in a different color. A central angle is radius to radius. Okay, and how many central angles does a pentagon have? Well, to find the central angle, it will always be 360, because remember this circle is 360, divided by, because all of these are going to be the same measure, same degrees, so it's going to be divided by however many triangles you have, okay, or however many central angles you have. And the central angles will always match the number of sides, so it's always going to be this. Okay, so if you look at this angle up here, this top one. That's always going to be half of the central angle. So this angle right here is going to be half of the central angle. To find that, half of the central angle, half of 360 over n, that's just 360 divided by 2n. See how I just put those two together? And that's how you always find that top angle. Okay, so if that's the case, then since I know I have my n in this one is 5, that means that this right here is going to be 360 divided by 2 times 5, which is 10. So I know this is going to be 36 degrees. Okay, so see, I don't have a special right triangle. That's 36. That means I'm going to be using trig. Okay, so this is going to be opposite. This is going to be hypotenuse. This is going to be adjacent. Alright, so I'm going to find my radius first, because that's first on the chart. I can find whatever I want, but that's what I'm going to look for first. So that means I need to find the hypotenuse of this triangle. So hypotenuse, I know my adjacent. Remember, adjacent and hypotenuse, adjacent over hypotenuse, that's cosine. So I'm going to put cosine of 36 degrees over 1 is going to be adjacent over hypotenuse, which is r. Now cross multiply, and this is one where you're going to have to divide. So the radius ends up being 8 divided by cosine 36. And don't forget that when you're using trig, you want to make sure that your calculator's in degrees. So here, when I plug this into my calculator, and you've got to make sure on this that you are rounding correctly, folks. It's 4 decimal places, but if you don't know how to round, then you need to make sure you get into tutoring. If you got a bunch of them counted wrong on your trig quiz because you didn't round correctly, make sure you come in so that your teachers can help you with rounding. But when you plug this in, this is going to be 9.8885. Okay, that's my radius. I'm going to write it up here. 9.8885 units. And this problem is 8 units. Now I need to find my side. Okay, so this was to find the radius. That's what you do. Now we're going to find the x, remember, which is half of the side. Alright, so opposite, adjacent. Opposite and adjacent, that's tangent. So we're going to write tan 36 over 1 equals opposite, which is x, over 8. Cross multiply, so x is going to equal 8 times tangent 36 degrees. When you plug that into your calculator and round correctly, you end up with 5.8213. Now, folks, don't write that down here for the side, because remember, that's x. To get the side, you have to double x. So, remember, the side is equal to 2x. So take this number right here and multiply it by 2. Okay, when you plug that into, if you plug this into your calculator, multiply by 2, you end up with 11.6247, and that's units. Okay, now to find my perimeter, remember your perimeter is just your number of sides times the side length. So that's going to be 5 times 11.6247. Alright, so when you plug that into your calculator, you get 5.1235. And remember, perimeter is still units. Almost done. Area. That's half the apothem times the perimeter. So to find the area of this shape, that means I'm going to say 1/2 the apothem, which was 8, times the perimeter, which is 58.1235. When you plug all of that into your calculator, you end up with 232.4940 units squared. Okay. We have 2 more examples. on this one, it's a hexagon, so that's n equals 6. Okay, so now I'm going to draw my apothem and my radius. This is my apothem, this is my radius, and I'm going to enlarge that. I'm just going to zoom it and draw it out here. Here's my triangle. Okay. Here's my pink triangle. This is the apothem. This is the radius. And remember, this is x, which is half the side, one of the sides of the hexagon. Okay, so the only information that I'm given right now is that the perimeter is 48. So all of these sides added together is going to be 48. I know how to find my side length because all I have to do, I know that perimeter is equal to n times the side length. So I plug in what I know. 48 goes here, 6 goes here, and this is s. To find s, I just divide both sides by 6. So s is equal to 8. So that will be 8 units. And by the way, this was 48 units. Okay, so to get x, which is right here, that's going to be half of the side, so this should be 4 units. Well, to get anything else in this triangle, I have to know what the angles are. I have to know if this is a special right triangle, or if I'm going to have to use trig. Well, I gave you a clue up here. It says answers in simplified radicals. Whenever answers are in simplified radicals, that means that you're going to be using a special right triangle. Okay, so to find this angle up here, remember, that's half of the central angle, so that's going to be 360 divided by 2n, or 360 divided by 2 times 6, which is 12. So we know that that is 30. So this is a 30, 60, 90 triangle. And just to remind myself, I'm going to draw my unit triangle over here. This is going to be 30, 60, 90 triangle. Remember, that's going to be x, 2x, and this over here is going to be x rad 3. And if you forget that, that is on your formula chart. Alright, so I know my radius right away. So see how this side is x, so we double it to get the radius. So here, 4 times 2, this would be 8. So this is going to be 8 units. The apothem, you just take the side length and multiply by rad 3. So here, that's going to be 4 rad 3 units. To get my area, this is going to be area equals 1/2 the apothem times the perimeter. So area is going to be half of 4 rad 3 times 48. Okay, so since the half and the 4 are right next to each other, you can just take half of 4. That's going to be 2. So this gets rid of the fraction. So that's going to be 2 rad 3. I just simplified this here. Times 48. And then 2 times 48 is 96. Rad 3. Okay, so the area is going to be 96 rad 3 units squared. Alright, last one. On the very last one here, we have an octagon. So I know that my n equals 8. Okay, let's start off by drawing my apothem and my radius. The apothem and the radius. Okay, and then I'm going to enlarge this triangle so I can see what's going on. Okay, so the radius I know is equal to 12 because it's given. Okay, folks, and that's units. I need to find my apothem, and I need to find x. Remember, that's half of this side of the octagon. Don't forget that. Okay, so in order to find anything out about these, what I have to know is what this top angle is up here. And that's 360 divided by 2n. So that's going to be 360 divided by 2 times 8, which is 16. So when you put that in your calculator, you get 22.5. So this angle right here, I'm going to turn this around. This is 22.5 degrees. So that's not a special right triangle, so I'm going to be using trig. So the next thing on my chart is the apothem. So that's what I'm going to focus on first. To find the apothem, A. Alright, to find the apothem A, I have to use trig. And that's going to be the adjacent. It's going to be opposite. This is hypotenuse. So I'm going to use cosine. Cosine of 22.5 over 1 equals A over 12. Cross multiply. So your apothem is going to equal 12 times cosine 22.5. And when you plug that into your calculator, it's approximately 11.0866. I can't stress enough, you have to round correctly. Otherwise you get it wrong and it will affect all of the rest of these. Okay, so 11.0866 units. Now I need to find this x down here. So to find x, I'm going to use trig again, and this time I'm going to use opposite and hypotenuse. Opposite hypotenuse, that's going to be sine of 22.5 over 1. It's going to be x over 12, opposite over hypotenuse. Cross multiply, so that means x is going to equal 12 times sine of 22.5. Again, I can't remind you enough, make sure your calculator is in the degree mode. So x is going to be approximately 4.5922. Okay, now remember folks, that's just x, but that's not in my chart. What I want is the side, and to find the side I have to double this. So my side is equal to 2x, so that means I have to take this number right here and multiply it by 2. So that's going to equal 9.1844. So up here, squeeze it in, 9.1844 units. Okay, perimeter, that's equal to n times the side length. So my perimeter is going to equal 8 times the 9.1844. So when you plug that into your calculator, you get 73.4752 units. And finally, my area is equal to 1/2 the apothem times the perimeter. So that's going to be 1/2. That's 11.0866 times perimeter, which is 73.4752. When you plug that into your calculator, and oh folks, you can also change, you can plug this in as 1/2, but you better make sure you put parentheses around it, or you can change this to 0.5 and then 11.0866, 73.4752. So either way, Just be careful when you're plugging this into your calculator. That's going to be 407.2951 units squared. All right, folks, there is an additional worksheet that you're going to need to print off and bring to class with you because that's going to be your networking assignment. So don't forget to bring the 11.6 extra worksheet. That's the networking assignment. It's going to look like a bunch of these tables together, and you're going to work together as groups with these notes to figure them out. All right, that's all for today of Notes 11.6.